Welcome everyone to today's webinar, Vector Search and Generative AI for Oracle Database Developers. My name is Nikki. I'm a marketing event manager for the developer initiative here at Oracle. And today we're excited to explore Oracle's groundbreaking Database 23 AI release, focusing on AI innovations like Vector Search. And today's webinar will be presented by Derek and Stephen. Without further ado, I'll pass it to Stephen.
Again, my name is Steve Nichols, and along with Derek Cameron, we plan to go over what vector search is today. So the agenda is pretty straightforward. I'll cover some introduction of what Oracle AI vector search is. I'll cover the topic of RAG, or retrieval augmented generation. That term is being used a lot these days. But yeah, and then I'll jump into briefly covering, some of the challenges or limitations with traditional document search. And then I'll turn it over to Derek Cameron. Derek will go into the deep dive of the vector search and generative AI demo. We're leveraging SQL and Apex. And then lastly, Pete Madura will cover the Code Innovate program. So now I'm going to dive into what is Oracle AI vector search or vector search. Simply, it's a technology that simplifies and optimize the searching of data, whether that data is stored in a document or in an image. It performs and helps you to search better from a semantic level. You may then ask yourself, well, what is a vector? And you'll see this in great detail during the demo. But a vector is simply a numeric representation of your data. That data can be in the form of a document or text. It could be an image. But what it is a vectorization or embedding is a sequence of numbers stored in dimensions that represents your data stored in the Oracle database. Here's an example, a simple example of an image. We take an image and we vectorize it, or we run it through an embedding process. It takes the data inside that image and creates vectors or dimensions out of it. You can see that the vectors will, and this is a simple example, the vectors will be generated based on the characteristics of the data or the image in this case. So each part of the image will contain a vector, and then you can use that vector later on to do searches. And if you take that same concept of images and vectors and you plot that on a two-dimensional array, you can see that when you start to group like images together in their vector format, you can start to see patterns. You can also see where images will look like certain images and some images won't look like images at all. And then once you have your data in a vector, then you can do what's called searching or vector distancing to figure out, well, how close is the image that I have to other images I already have in my database. And again, this is a simple image example. But with vectors, you can start to do calculations on distances and search to find like data compared to what you want to search with. The same holds true for words or textual data. And this is really what we'll focus on today with text vectorization and chunking. You have text, you want to search on a set of text or words and then get similar text back from your searching. This is what vector does. It allows you to search on the vector level to find distances, and you find the ones that are closer to one another. So now that you know what a vector is and looks like, how do you use a vector? And well, I should say, don't worry about taking notes. All this stuff will be recorded. And we have a companion GitHub document that will provide all the code that Derek's going to show in a few minutes. So just sit back and relax and watch the presentation, and you can reference the documents at your own leisure in the future. So you ask, well, what can I do with a vector? Well, the key with vector search is you can take documents, images, etc., and you can combine that with the relational data that you already have in your Oracle relational database, and you can search on it. And so that's great. You can think of, the Oracle database is what we call a converged database now. Traditionally, we store relational data with rows and tables and columns in it. we've added JSON support, XML support. We can store spatial graph data. And we now have generative AI, natural language to SQL functionality with Select AI. And now we've added the vector technology to the existing Oracle database. So that's great. You can do all that other data searching, and now you can do it based on vectorization. It helps to eliminate the need to have to move data around to other databases, and it's all in one database. And so when you start to play with and experiment with the vector technology within the Oracle database, you're going to see some new features. When you start to work with the vector data type, when you'll see here, Derek will create a table. That table will have columns, as we're used to seeing, but there's now a new column type called vector data type. There's also vector indexes. These indexes, like any other index, will allow you to search and query the vectors more efficiently. There's vector functions and operators that will allow you to build that vector database or vector stores in the Oracle database. There's functions and SQL statements for the chunking process, where you take textual information and you create chunks out of it. And then you take those chunks and you create vectorization or embeddings. There's SQL statements for that. We have SQL statements that then allow you to query the vector information to find distances. You want to find data that's similar to what you have. We do that based on a distance calculation. And then we also support JSON compatibility with the vector data type. And then we'll also cover this, and this is important. Vector search by itself is great, but then when you augment that, or when you include that with retrieval augmented generation, or RAG, it really is a powerful tool. And this is what I'll cover now. And so adding semantic search to a relational is great, like I said a minute ago, but when you can add the power of generative AI, large language models, to the vector searching, or integrate that in with vector search, it becomes really powerful. So what you do is, and you may have heard the term RAG a lot. I have recently, especially with all the buzz around AI. But what RAG really is you can take your vector search features and functionality. You can help to find information that you want, or content that you want answers on. You can then take that information that you find through your vector searching, augment the prompt or the question that you're going to ask your Gen AI service, and then it helps to get a more accurate answer, a better answer to your questions. And you may ask yourself, well, how does that look from a user standpoint when you take vector search and RAG and you combine it together with a Gen AI service? So the way it works is the user has a question. You have a question. They type it into whatever application you're using. That question is then vectorized by the vector database or vector functions. It's then passed to the vector data store, and then you run queries against that vector store with the vectorized question that the user just typed in to define content and information in your private database that's relevant to what the user asked. And once you find that similar data or data that you want to use, you then take that information along with the question that the user asked, and you generate a prompt, and you pass that prompt to a Gen AI service, and then the Gen AI service will answer that question based on the augmented prompt that you were able to create with that vector data. So again, the user types it in, vectorizes the question, compares it against vectorized data that's already in the database, generates a prompt with that vector information, asks the LLM, and then it retrieves or returns an answer that is relevant and accurate to what they asked. So in summary, Oracle holds a lot of the data in a relational format. We now have the ability to store data in a vector format, along with the other formats that we have today. We think that's powerful because it's one database with all different types of data stored into it. You don't have to worry about having multiple databases, multiple issues with syncing data across the databases. It's all in one place. Since it's all in an existing Oracle database, it supports scale out around rack, sharding, and partitioning. We support indexing just like traditional indexes for vector search. And since we're using the Oracle database in SQL, it should be a lot easier to pick up and leverage if you're a database developer that's familiar with SQL already today. So before we get into the demo part of Derek, Derek's going to show. I just want to briefly touch on, what traditionally we do when we search. In the old days, we would search based on keywords. Those keywords you may spell wrong, or the word itself may have multiple meanings. If you're querying for content based on keywords, there's some limitations around that, mainly around the fact that there's no context to what you're searching for. You're just asking for a literal match of this string to that string without any context around the entire document or text that you want to search against. And then also, when you get the results back, they're just the results. There's no interpretation or additional, augmentation or generation around that information. Using a Gen AI service, you can then take those results and augment it and interpret the results a lot better. So traditional search is a little more challenging than vector search with RAG. I also want to call out, you may have seen a lot of different presentations and demos and articles on vector searching and RAG today. There's a lot of different approaches to this solution. I've listed some of the key ones that you may have seen. Using Python libraries with LangChain. There's a lot of different LLMs out there for embedding and chat. LLMs, you can use the Meta Llama ones, Hugging Face LLMs, there's OpenAI, Cohere. You'll see solutions around Jupyter data science notebooks, and they're all valid and very applicable solutions. And the key is that you can do all these things and still leverage the Oracle 23 AI database. We're just going to show you a solution today that is leveraging entirely all Oracle and OCI in the Oracle Cloud. And we're going to show you a solution, or Derek's going to show you a solution that leverages SQL and PL SQL to perform the uploading of documents to your database, the chunking of your data, the vectorization of your data, the searching of your data. We're going to leverage Apex as the front end. We're going to use large language models that are hosted by Oracle's OCI Gen AI service. We host Cohere, Meta Llama models today. Nothing against Python. I love Python. I program in Python a lot, but there's no knowledge required to implement this solution or any third-party libraries. The nice thing is you can see what we did today and apply that to an existing database in 23 AI. We'll demonstrate the entire process. And then, like I said earlier, we'll provide all the code that Derek shows throughout his demo. Nikki will send out an follow-up email with the recording along with the GitHub notes that you can follow along in the future. So at this point, I'm going to turn it over to Derek, and Derek's going to walk through his portion of this, where he's going to demo real time what we've built or what he's built.
Great. Thanks, Steve. You can hear me?
Yep.
Okay. Yeah. So let me share my screen. And first of all, sorry, folks, I've got a bit of a summer cough here, so I'm going to be sipping water occasionally. It's got this tickle in my throat. I'm coughing. So like Steve said, there's a lot of solutions out there. One thing we noticed is all of them seem to, at least the ones we've seen, seem to leverage things like LangChain, things like Python, Jupyter notebooks, a lot of different moving pieces. And I'm a SQL guy. Full disclosure here, I'm a pure SQL guy. What I felt or feel is that a lot of this stuff, most of it can be done in pure SQL, meaning it's much simpler. You deploy the autonomous database and you start writing SQL. And the SQL code that I've got compared to a lot of the Python code is far less verbose. So yeah, if you just have an ADB instance, you have data and you have access to the OCI, you have credentials that Steve's shown, you can actually just code this and implement this very easily, very quickly. So yeah, let me walk through the code that I've got here. You'll notice I'm in SQL Developer. I just want to touch on the fact that I wanted to get a somewhat semi-realistic example here. And so we're using Texas legislation bills. I downloaded 20 of those documents. If I go to my here, you go to this site, and Steve's got this in the GitHub. Again, all of this code's in the GitHub, so you can reproduce this pretty darn easily. I downloaded these bills. I actually looked at them and tried to make sense of them. They're actually kind of complicated. They're long, complicated. I was amazed at how effective the LLMs were at interpreting the content, searching through it. I'm going to be searching across these bills. I'm going to be asking questions of those bills. It's going to find the bill content in the appropriate bill, and it's going to interpret it for me. And I'm going to ask follow-up questions that are going to reference previous questions, and all of that's going to be shown to you here today. So let me go back to code. And I'm just going to touch on this briefly because when Steve and I started on this project, we actually didn't have 23 AI and ADB. You don't have to have ADB, but it sure makes it easy. We deployed DBCS 23 AI on it. Oh, then we had to install the DBMS cloud package to make it a lot easier. I've found that the prompts and the responses are more than 4K, and the default for DBCS is 4K on the character. So that meant an upgrade, opening it in standby mode. Oh, that's another step. And then we wanted to use Apex. Oh, we installed ORDS on a compute and configure that. So none of that's required. ADB has all of it. So be thankful if you want to try all this, please, suggestion, use ADB, but it can be done on DBCS. So yeah, tables. I created a vector legislation table. I got the code for that. Here it is here. And I loaded the documents. I'll show you how to do that. I will show you how to do that. Not much code. Upload these to object storage, execute a small code snippet to load them into blobs in the database. Legislation vector. As Steve said, we have a new column. It's just a vector column. Created that table. We're going to take the text in the PDF documents. We're going to convert them to text. We're going to create chunks, and then we're going to vectorize those. And conversations. It's very, very useful to have conversations tracked because that's the workflow, right? You're going to ask questions. Questions are part of conversation. We have a conversations table. Just an FYI, I initially envisioned this using sys context values. If you're a lifer like me, working with Oracle over 30 years, I was aware sys context has been around a long time, but sys context only can store up to 4K. And it worked, all my stuff worked for a while, and then it didn't because my chat history grew and it blew out the 4K. So just so you know, I found that the conversational tracking with the prompt and the chat history, giving you what did I ask, what was the response, what are all the history of all the questions that were asked, and where were the chunks and what were they used, what was used to answer the question is all in the prompts table. So this is really handy. I can go back, look at what was asked. All of it's just JSON. If you are not familiar with JSON, everything we seem to be doing this day is requiring some knowledge of JSON. I've done an hour-long presentation focused purely on JSON. I would encourage you to take a look at that. But we have JSON functions to parse all this stuff out, and I'll show you that as we move forward. So loading documents. I put them up into object storage. So let's just look at that. We're using DBMS Cloud. This is now on the fly, reading those documents. Oh, and I have the Onyx tables in models in there as well. We loaded those. But for this exercise, I'm only looking at PDF documents. So I'm loading the PDF documents. Really simple, really fast to load those documents. There's the code for it right there. Load the files. And I'm just going to brief segue here. We started using Onyx models, and there was a question on chat about Onyx models. The ones that we looked at, TinyBurnt and all mini LMs, they do not work very well. They work quite poorly. But if you find some that work really well, you can load them. And so I got the code for loading them here, copy the Onyx to object storage and then to an Oracle directory. And then here's the load exec, load the Onyx model into the database, and then insert, and then you got to vectorize it, use those to vectorization. Here's the code here. Again, we did not use it. We did initially, did some testing, didn't get good results, started looking into it. Let's use the Oracle ones. They work really well, but if you have other ones on the internet, open source ones you want to use, here's how you can use them. So yeah. The next thing I want to cover is just like, okay, we have this end-to-end chaining, using these chaining functions to do everything in one step, but I like to break things down into little pieces because why? Well, some of this vectorization I did was not on documents. It was on just varchars in the database. So I don't need the document to text steps. Like, break this down for me, please. So I've included a bunch of code snippets in here so you can exercise, you can just take little pieces of it. There it is there. It's taking my documents that are in legislation here, and it is just converting them to text. That is the whole document, but I'm just showing you how you do that. Then we're going to chunk them. So that's the chunking piece. And this is all going to be chained together in the end, but let's chunk them. There's the code for that. Love SQL. There it is there. File name. This is doing it on the fly, by the way. There's no kind of PL SQL here. It's just SQL. Query the documents. Show me the file size, the chunk ID, chunk position, the chunk size, and then the text itself. And we're using JSON value functions, just so you know here. JSON value, chunk ID, JSON value, chunk ID, chunk offset. This is all in JSON. Don't be afraid of JSON. You're going to love it. Just seems like everything we do, as I said, these days is all done in JSON. Once you get familiar with it and comfortable with it, you'll be off and running. So there's that. And then let's do the embedding query. This is where the heavy lifting goes. This is where your steps go from seconds to minutes. It's using a large language model. We're using Steve's vector cred, vector versus the OCI cred. Remember, Steve emphasized we have multiple creds at play here. Don't get confused. OCI creds and vector creds are different. We're using a vector cred here. There's the embed text URL. We're going to put all this together in a function in a minute. There's the model. It's internal. We have lots of customers interested in vectorization and large language models. And as soon as they start using things like the open source models are like, hang on, we can't have our data going outside OCI. So this is all internal OCI. I put a filter here, row num equals less than 11, because when you run this, even for 20 documents, 1,400 text chunks, it's going to take minutes. And if you have, I've got one with 60,000 text chunks. It took, I don't know, like an hour or more. So yeah, here it is here. There's the chunk text. There's the vector. Steve kind of gave you the theory behind that. Here is the actual vectors themselves. Won't get into the detail on that. All the vectors have vector dimensionality. Kind of one of the key things to know is querying a vector and embedding vector, you have to have the same dimensionality. There is a SQL function to return the dimensionality of the vectors. And if you look at the data and you find you have a dimension mismatch, you can use a dimension count function to return that. So just FYI on that. And then combine all the steps in one flow. So I'm going to do the document to text, text to chunks, chunks to vectors, and I'm putting a filter on it again. Why? Because otherwise it will blow up with service limits and it will take a very long time. So I'm just doing the first 11 rows. And also, just by the way, you'll again see code out there. People use cursors. Cursors take lots more lines of code. I rewrote most of it to be just plain tables with straight SQL, no cursors, don't need cursors like SQL. So here it is here. Here's an end-to-end on the fly, no PL SQL, it's just SQL. ID, file name, chunk size, chunk ID, chunk size, position, etc. And there's the embed vector. Well, if I have this, I have everything. Like I have everything. I've got the text, I got the chunks, I got everything. But I've only done it in 11 rows. I need to do this whole database. And so I ended up running this. It blew up with service limits. So I ended up changing my code and update the vector in micro batches, looping through rows that don't have vectors. This is just my kind of quick and dirty way to do it. You have batch size, default is 50. I reduced it to 10. And I just said, just find ones that don't have vectors, where embed vector is null, and then just generate the vectors and loop through this over and over until it's all done. And so that's kind of a way around your service limits thing. This is just, our service limits are really low. We're in sales. They don't give us a lot of, service limits that are they're very low. So you may not run into this. So that's fine. We've batch vectorized all this, but what if we want to have an application? We need to be able to upload documents, vectorize them, and be able to pose questions to them. I created a package for this. This is all net new. I created a package history, package body. I add a conversation because when you log into Apex, if the conversation is new, it creates it automatically. I've got a form in Apex to say, I'm done my conversation. I want a new conversation. It's calling this here. And then when I start prompting and I start asking questions of my data, it's going to add the prompts. It's going to add the response, when it was asked, the chat history, where it got the answers. All of this is in this package procedure here. The other thing to note, it's autonomous pragma, autonomous transaction. Why do we do that? I am doing this in a function. Functions require autonomous transactions if you're going to be doing data updates. Just an FYI, because you'll get into errors and saying, oh, you can't do updates in a function. Well, yes, you can. Autonomous transactions been around a long time. I've used them many times over the last couple of decades. They're really useful for doing things like updating data in a function, and I'm going to be using a function. So yeah, there it is there. The adding prompt, adding a conversation, adding a prompt, another autonomous transaction. And then you do need to generate the vectors. So we're going to be updating doc in Apex, and I need to vectorize it. And so all that logic that I showed you up there is all in a procedure. And I don't need to worry about service limits. I'm just uploading a document. I can just do the whole document. So no worries about that, not doing mass data updates. So there's the logic there. And then I've got a trigger for the creation of vectors on the upload of a document. There it is there. And now here is kind of the magic sauce for all of it. We have a function. The function pulls everything together. I can run it in SQL. I can run it in Apex. I can run it in a Node.js application. This vastly improves and simplifies everything. It's all in a SQL function versus using open source and Python and all that code. You can actually do that in a very compact function right here. So notice here, we've got an embed model, a query model. We've got the embed text. We've got the chat endpoints. We have a provider. We have Steve's two credentials here. It does reference a compartment. And then what is the process? This takes as endpoint a question. It's a prompt. I can do this in SQL. I will do this in SQL. All it is I'm going to ask a question. I'm going to pass you my question. You will go through and vectorize the question right here. I'll vectorize the question. I will then crawl through my database. I will pull out the code snippets based on the semantic meaning of the question versus the data. It's going to append it. I have the first 5 rows only. If I only had one, I wouldn't need to append it, but I'm going to get the first top 5. And I'm going to append those, and I'm going to track where I got that in the chunks. I'm going to do a little bit, and then I'm going to say, hey, LLM, here's all this information. I have a question for you. And here's the question added to the text. So you have all this text. Then you have, I'm going to ask you a question. This is kind of, this is prompt engineering, a crude method of prompt engineering. You can get into much more qualification of, oh, here are the rules I have, Mr. LLM, for answering the question. I've kept it really simple here, but it's just SQL. You can qualify it with, here's the rules. Don't tell me the answer. If you don't know it, don't go outside your domain, outside this text. So that's qualifying it. But here it is, question. And then I wanted to be able to have it pure standalone in SQL. If executed in SQL, the app session is not set. So I set it, otherwise set it in Apex here. And then here's the request. I'm going to send it. The chat history is managed here. So it is managed by this function. It does manage chat history. So there's the chat history there. And there's the chat history before. And then I'm going to set it, the chat history after. There it is there. So, oh, I'm appending this conversational context. I'm going to have the output, and I'm going to have the response. I'm going to parse it out. It's a JSON value, JSON history after. What does that response look like? It looks like this. There it is there. This is the response to this question right there. And there's the chat response. There's the chat history. And the function, we're using a JSON value to pull this value out, the response. And we're using a JSON query to pull out the chat history. So let's look at that. Here it is here. And I did not purposely misspell this. I accidentally misspelled it, but then it was so good at translating and fixing it for me, I left the spelling error in there. So I'm just doing a SQL function, and it's that function up above. Super easy. Hey, if I can do it in SQL, I can put it in any tool I want. So there's this there. I'll copy that. Let me go back into here, JSON here. I'm going to paste it here. And there it is. There's the answer. There's the answer coming back. Super helpful. It's interpreting it. It's crawling through a fairly cryptic legislative bill, and it's finding it's in Bill 9. Doesn't know it's in Bill 9. Finds it and returns the answer there. Let's go back to here. I'm going to do a follow-up question here, which is, are there any financial implications if it? Well, what is it? It is what I asked you earlier. It's that response there. Let's look at that. And so, yeah, there it is there. And let's look at the conversation that's getting added. There's the conversation. It was just generated now. Let's look at the responses. There it is there. I've got the prompt. I've got the response, which you've seen. I've got the chat history here. And let's take the chat history there, copy it. Let's go back to here. We'll go back to there. Select all, delete, paste. Oh, what is all this stuff? I'm going to format it. There it is there. I've got the whole chat history generated on the fly. I'm capturing it in the prompt table, and I'm bringing that forward. Every time I ask a new question, it builds that chat history. You can see that chat history chews up tokens. Just a word of caution here. You want to have a conversation that lasts hours. Good luck. You're going to blow up your tokens. Just be aware of that. You probably in your application want to set some sort of limits on how many questions are asked. How long does this conversation go? Because all of this is tokenized. And yeah, and the question, you'll see it in here. My questions are embedded in the JSON here and appended. There it is there. Question, I added this. Are there any financial implications if it's passed? That's it right there. So yeah. So I'm going to switch gears a little bit here. I want to go to Apex. So I'm gonna reset this so you have a nice clean setting. Truncate prompts, truncate conversations. Go here, go to page designer, sign in again. Let me bring up Apex. I'm using vector. A vector, and I've got a bunch of stuff in here. I'm not going to strip all of it out just for this demo. I'm going to run the application. Of course, I have to log in again, so let me do that. Let's do that. Run the application, and I'm going to log in again. And yeah, this is another one. I'm not going to get into this, but if you hit learn more, it'll issue an LLM, it'll issue a model. And 24.1 added support for setting web credentials and registering your services in. It's super easy, but right now it doesn't support it. You need to go to outside models to support multiple prompting. So just and they'll be changing that, just an FYI. So I'm not going to be using those in my application today. We're going to use our SQL, for pure SQL, Texas House bills. I've got tiles here. I've got a picture, the first page of my Texas House bill. Here they are here. I'm going to search my house bills. And this is a template. Thanks to Shane, our Apex expert. Shane gave me this template. I didn't build it. Shane's our Apex expert, and he kind of engineered this so that I could do this Q&A against my data. Let's go back to the prompts. Let's go here, and let's ask the questions in Apex. Copy here. And yep, let's ask this. It's using a template, formatting it, running this, creating a new conversation, by the way. And that conversation was created when I log in. But if I want to create a new one, I've got a button here. And so, yeah, and I'll expose a couple of those things in a couple of minutes. Let's ask another question. You'll see how this conversational UI works. I really like it. So we're going to go back here. I'm just sticking with the usual one that I've been working with here. Copy. Let's go here, go down here. I'm going to ask a new question. How does that look in my conversational UI in Apex? It's got this Q&A, question answer. Here's my questions. Here's your answers. I really like it. Separates the prompting. There it is there. And there's the responses. You saw that in SQL. You saw that in the prompt table. And now you see it formatted here in Apex. Super. I like it. Let's go to update legislation. Let's create a new one. I'm going to upload my own document. I'm going to upload the Constitution. And so I don't need all this other stuff. I mean, of course, I could add that, and I could engineer this so the file size and all that stuff's captured. It's kind of a quick and dirty. I'm going to choose my file. I'm going to go into documents, go into vector. I have got the Constitution. Yes, it's the real Constitution of the United States. And I elected to call a DBMS job. Why? I had a little bit of trouble with the fact that I was updating and inserting and running this all at the same time. I had a problem with mutating tables. But more importantly than that, I felt it was much better to actually kick off a job because the vectorization of the document and text chunking takes about a minute. And you don't want to have this spinning dial in Apex. So I kicked off a job. And so let me go to SQL here. Let me go to legislation. Let me just, here's my new, I just added this right now. And let's go to legislation vector. Let's see if it was added. IDs 1 to 20 are there. And all right, we have a new document here. It was vectorized in about, I don't know, 30 seconds. It was executed. The DBMS job did all that for you, executed those procedures that I showed you earlier. There's the Constitution, blah, blah, blah. Again, merged in with all our other data, allowing the user to upload their own content. And now let's go to ask a question, summarize the Constitution in one paragraph. And let's go back to Apex for that. Go to search house bills. And I'm still in the same conversation. And I am going to ask it to summarize the Constitution in one paragraph. And you'll say, yeah, but it already knows about the Constitution. How do you know it's going against the data? Well, I know it's going against the data. Why? Because when I go into here and I go into prompts and I execute the prompts, I have got my references in here. And there it is there. My references, which I tracked in my function. Here it is here. It's the document. The document is the Constitution. The chunk ID is 39, among other chunks that are used to summarize the document. But I think it does a pretty darn good job of crawling through the whole Constitution, which is, I don't know, I can't remember how many pages it is, 60, 70 pages. And here it is here, down here. So yeah, here it is, establishes federal system, blah, 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 blah. So here it is. I've got a chat interface where I'm querying it. I'm using vector search. I'm getting the LLM to interpret. So it's combining not only search, not only semantic search, but interpretation of those results all in one step. All of this done pure SQL. Choose your application of choice, be it Apex, be it Node.js, be it whatever you want. You just need the PL SQL function and you are good to go. So what's the wiring underneath here? If I go to utilities, whoops, let me go to page here. Let me go to the login page. The login page has processes for kicking off a new conversation. It's right here. There it is there, chat history package, add conversation, app user, app session. Again, I use a separate function to add the database user, so you can use database or app users regardless. I go in here and let's go into page. Let's run the application. Let's just go into page, search house bills. And actually, I will go in here again and I'll go into shared components. This is the plugin that Shane had given me. It does require a plugin. We'll give you the plugin in the Git repo, just FYI. And in here, of course, it's all, actually, I don't think I actually had to do anything in here. Super simple. Let me go back to the application. I'll show you one more piece before we hand it over to Pete Madurdy to talk about the code Innovate. I'll run the application. I'll go to the search house bills page. I'll go to page 12. And we will just take a look at that. Invoke API. There it is there. That is the function. That is the function right there. It passes a parameter. If we go into here, there's the house bill detail, the response, the conv ID, the LM conversation, the columns. Here it is here, right there, passed on. One more thing. I keep saying one more thing, but I truly mean one more thing. Here, we'll run the application. If you want to search the Texas house bills and then you want to actually look at the PDF document, here it is here. So you can just select a document, select the Constitution, whoops, Constitution here. So yeah, we've got a PDF viewer right embedded in Apex if you want to actually look at what it is that the user is searching. So yeah, I think I'll leave it at that. We'll publish a little bit more information on the GitHub repository that includes the code right now. Steve and I will update to give you all the details on how you can replicate this. Just SQL, just autonomous database, just Apex. Apex comes with ADB, so all you need is a autonomous database to do all of this. So with that, I'm going to stop sharing. And Pete, if you want to talk about the Code Innovate program.
Thank you very much, Derek and Steve. That was a great session. So I would like to take a few minutes to talk about the Code Innovate program here at Oracle. So what is Code Innovate? Simply put, it's a customer enablement program where Oracle engineers team up with the customer to help them build out a first pass prototype for one or more of their use cases using Oracle technology. These events are run entirely online and allow your organization to jumpstart their cloud development efforts. Let's quickly walk through what the experience looks like. We start by understanding your use case and the service or services needed to meet the requirements. Next, we pair you with Oracle engineers that will work with your team. And at the end of a 20-hour sprint, we'll help your organization build out a first pass prototype based on your use case. You do the work within your tenancy with our expert guidance. Now, here are some of the requirements. We ask that you commit 4 or more developers to an event typically, and these run for 5 half days or 20 hours, and the start time can be very flexible there. These events can handle more than one use case simultaneously, and we ask for about 3 weeks lead time to fully understand the use case, assign appropriate engineers, and align the schedules. Here's what a typical event timeline looks like. We'll determine an event week after we've discussed the use case. We'll assist with any configuration and/or provisioning of services prior to the event week. And then we'll provide a structured learning on the service or services that will be utilized for the event, so developers will have some familiarity before going into the week. Then we run the event. We offer this program for a wide variety of services available on OCI or Oracle Cloud Infrastructure, such as Oracle Digital Assistant, Oracle Analytics Cloud, Apex, Oracle Integration Cloud, and many more AI-enabled platforms. If you've already got a use case in mind and wanting to learn more about the program, feel free to email us using the address on the screen, or simply enter your email and name in the Zoom chat now. If you're already an Oracle customer, feel free to reach out to your account executive about the program. Thanks for the time today, and we hope to hear from you.